Hello everyone, today we are talking about remote sensing images and the characteristics of remote sensing images. Uh, Hope you learned something from previous two videos, and if there's something to improve, give us a feedback in the comment section. And first thing first, so first of all we should know what is a remote sensing image. In our day-to-day activities we call picture, photograph or an image basically to represent the same thing, but in remote sensing these three words have different meanings respectively. Here let's see what is a remote sensing image. So image is an, in simple words, a pictorial representation of an object or a scene. In other words, if we expand this definition a bit, it can be defined as a pictorial representation of data acquired by satellite systems, such as direct readout images from environmental satellites. So you can see an image is not what we call a photograph. That's something we need to understand. In remote sensing, these two have separate meanings, and it's something more than a picture. In remote sensing, image is something more than a picture. It contains measurements of electromagnetic energy, as we discussed before, which we collect data with respect to electromagnetic spectrum. Reflected wavelengths and other things are measured, and we these measurements are contained in a remote sensing image. So in remote sensing we deal with these measurements, and that's something not far concerned in a photograph. And it uses a regular grid format with rows and columns, and smallest unit is called a pixel, and we come to that in later. It's one of the key characteristics of a remote sensing image, and in each pixel contains a digital number we call otherwise DN value, and also each wavelength band measured, and also it is stored in a separate layer. And let's look back further into these remote sensing images. And remote sensing images, these images are divided into two categories: digital and analog. Digital remote sensing images and analog remote sensing images. Analog images converted later into digital images, but analog images, when we talk about analog images, those are produced by photographic sensors on paper, based on media, based on paper based on media or transparent media or those kind of media. So analog images are produced by photographic sensors on paper based media or transparent media. So variation in the scene characteristics are represented as the variation in brightness. So characteristics of the data we need to, the variation, how the variation flows through the data set, we need to identify the characteristics are defined to the variations of brightness when it comes to analog images. So this variation of brightness is called a gray shade scale. So when objects reflect more energy in gray shades, it's bright. It will be dark if objects reflect less energy. So you can see how the analog images works. And when it comes to digital images, those are produced by electro-optical sensors, and they are composed of tiny equalized square pitch elements, which were called, of course, as pixels, and they are arranged in a two-dimensional matrix. And in digital images, with each pixel is associated with a digital number or a brightness value, is represented as BV or gray level, which is a record of variations in radiant energy discrete form. And also digital image can be said as an object reflecting more energy, records a higher number for itself on a digital image, and things go on like that. So basically, remote sensing image is a raster data. And then let's look at the first characteristic of remote sensing images. If you want me to list out these characteristics, pixel, digital image data, scan line, image band, image file format, image size, and DN value. These are the basic characteristics of remote sensing image. So pixel is the magnitude of electromagnetic energy captured in a digital image, which is represented by a positive digital number. And so digital numbers are in binary digits, in format of binary digits, which vary from 0 to a selected power of 2. So when it comes to pixel, it is the smallest part, as I say, which the sensor can detect at a time of an electronically coded image, such as computer display. And also pixel is a contraction of pitch element, and it can be defined as the smallest part which the sensor can detect at the time, or as a two-dimensional pitch element, that is smallest non-dividable element of a digital image. Smallest non-dividable element of a digital image. So when it comes to digital image data, these are the metrics of digital numbers. Digital image data, metrics of digital numbers, and there's one matrix or one layer for each satellite band, and each DN value corresponds for one pixel, and images presented as 2D arrays or matrix, and each pixel has a location and digital number associated with it. And when it comes to digital number, it's a relative measures of radiance, and but it's not reflection, of course. As you see, position of pixels can be represented in rows and columns. So digital number, when it comes to digital number, as I was speaking, it can be converted to ground reflectance if you know atmospheric properties are known, and satellite calibration coefficients are known. You can be converted this data into ground reflectance, and the range of radiometric resolution from And then let's talk about image size. It's simply the number of rows and columns in a scene. Earlier I told you digital image data can be defined in metrics, so number of rows and columns defines the size. So metric size, image size, to basically the same thing. And image file format, here we talk about three data types, three file formats of the remote sensing image: band sequential and band interleveled by line, and band interleaved by pixel, and BIL and BIP respectively. So we talk about these file formats in later sections, so we'll look into that later. Then comes to auxiliary data. It is about when an image scene is composed from multiple files, and each of these files has to be composed of multiple records. So data other than image data in the files are called auxiliary data. These data involves actually a description of a file, image data, platform, sensor, and also data processing and other data such as include telemetry. These data represent with as the configurations of world standard formats such as LDWG, Landsat Technical Working Group. So these files, auxiliary data files, are actually, one is the reader file, the other one is an image file, and trailer file and supplemental file. So reader file include three records, header file, auxiliary file record, and annotation record. So image file basically includes image records which are such as line information, spectral data, such things, and quality of data will be represented in trailer record, and information about satellite detector and data correction will be included in supplemental file. So let's look at an example when it comes for when it comes for area with a certain volume. Okay, when we need to see the content of auxiliary data, so you can see there will be a volume description record. This may include which may say to be volume descriptor. So this is one of the files included in auxiliary data. The content of auxiliary data will be in volume descriptor. This may include basically the structure of this volume and description on data according to each volume or considering all the volume. And then there will be a file pointer record. This will include location, kind, size for each file in volume. And of course there will be a file descriptor record which includes number of records, length of records, data position, explanation on data for each file. Before that there will be a text record. What is a text record here? Even without mentioning here, it is this text record, you have to keep that in mind. It includes the comments given by the data collector actually. That's a text record. It's not something always mentioning, but it includes a text record. So after that there will be when it comes to reader files, there will be a header record, which includes header record and auxiliary record, and also annotation record, which includes reader file, which is in auxiliary data. So in header record, this includes the description of the scene taken by the remote sensing image. Remote sensing image has taken to on particular scene, and this explains the scene. How this explains? By giving you the location of the scene center and also giving you the time which this scene occurs, and the correction methods, and we will explain later. There are plenty of corrections we need to make before analyzing, when we analyze remote sensing images, and correction method which we use to do it is explained while presenting the scene through header record, and the number of bands, level and number of bands, of course. And we comes to the auxiliary record. It will explain us the correction process for data for the correction process. So data which need for the correction process are presented to us in auxiliary data. What are these data? Of course, WRS value, projection method, skew, angle, and satellite altitude. All these are the corrections. We need to do the corrections based on satellite position and other stuff. Basically, these are data we need to do. If we need to do a correction, we have to use these type of data. So those are presented in the auxiliary record. Then we come to annotation data, the last part of reader file, and annotation for scene is described by these character data set of characters in reader file, annotation data. Then we comes to image data record. Image data record includes the image records such as line information and spectral data, and trailer record. Then trailer record includes the quality of data, and then we come to supplemental file, which includes the information about satellite detector, coefficient of geometric correlation or correction, and telemetry data, etc. If you want to have a screenshot, I'll wait here. You can have an idea about these images, this content of auxiliary data. Then we look, next characteristic is a scan line. It is a row of pixels which is represented by moving a sensor from left to right or collected through the use of linear array of photo detectors. So it's moved from without breaking. It's a chain, like moving like take a chain of photographs. This chain of photographs can be defined as a scan line which will be taken from while a sensor moving from left to right. So image band or channel can be defined as the information that gathered or stored in the channel can be said to as the information from a narrow wavelength range. This is divided into two parts. One is single band, of course, when only one band of electromagnetic spectrum is sent to the output device and renders the pixel in shades of gray. This is said to be a single band. Another type is the multiple band. Multispectral sensors are used here. They detect light reflectance more than one or two bands of electromagnetic spectrum. So that is what we call a multiple bands. So that's all about characteristics of remote sensing image. So today we discuss what is remote sensing image and what are the two types of remote sensing image, digital and analog, what are the differences of them, and we have a rough look on each characteristics of remote sensing image. So hope you learned something from today and this and we will continue our lecture series with another topic that will be so if you want me to continue on resolution, it's okay, or otherwise scanners, they are big scanners, and there were requests to continue again about the process of remote sensing again by explaining a little bit more. So if you want, it's okay. So I hope you learned something from this video. So leave a comment if there's anything more to discuss, and have a nice day. Thank you all.